Hello students, in this video I am going to go through three examples with you guys on how we can verify whether or not two equations are in fact inverses of one another. So let's take a look. In the previous videos we've gone through these two equations, the applications of these two equations, which was a conversion from Fahrenheit to Celsius and vice versa, and we've concluded that actually these are inverses of one another because we're going from Fahrenheit to Celsius and then in reverse from Celsius back into Fahrenheit. So this is the whole idea behind what an inverse is. Okay, so we know these two are indeed inverses. Now, how can we verify whether or not these two are inverses of one another if, let's say, we didn't go through the process of actually solving, right, the equation? Because not all circumstances, not all equations are going to be as easy to solve. Okay, so there is actually a way for us to go through this. As it turns out, if I take the equation, let's say C, this equation right now, I have C is equal to 5/9 f minus 32, and I know C is a function of f, right? So what I'm going to do, okay, is wherever I see f, okay, I am going to make the substitution of 9/5 C plus 32. So what I'm going to do is I'm going to punch that in there. So I'm going to have 9/5 C plus 32. So again, what I'm doing is I am figuring out what is C of f in other words. C of f is equal to 5/9 f minus 32. And I know f is equal to 9/5 C plus 32. So therefore, again, wherever I see f, I am going to replace that with 9/5 C plus 32. And if I go through the mathematics and check out what happens here is, okay, I distribute the 5/9, something strange happens, right? The 32 minus 32, that becomes 0. So I get 9/5 C. I end up with this. I end up with C. Okay. Similarly, if I do this in reverse, okay, and I say, oh, since f is a function of C in this case, okay, and I get 9/5 C plus 32. Wherever I see C, I am going to replace that with 5/9 of f minus 32. So what do you think is going to happen in this case if I do this? Right? So let's see what happens. I am going to make the substitution, and I end up with 5/9 f minus 32, and then plus 32. So now what I'm going to do is I'm going to multiply the 9/5. So I end up with 9/5 times 5/9. That's just 1, right? So I end up with f minus 32 plus 32. I end up with f. I end up with f is equal to f. And before I have c is equal to c. This is an identity, right? This is telling us that the two equations that we have right now are indeed inverses of one another. This is an identity, okay? So let's try to put this in a more general case, okay, where there's absolutely no context. Again, I keep on going to this like higher level of thinking where there's like no context. That is because that is the direction that we have to take this in, because in order for us to apply things to the real world, we have to understand the abstract. We have to understand the subtleties, okay? So let's see what happens if we apply this in a more general sense. Okay, so right now, okay, we have these two equations. One is the inverse of the other, And I'm telling you, we've actually done this example in the previous video, okay, where we found the inverse function of the square root function to be the quadratic equation. So this is what I'm going to do. I am going to substitute in, okay, I am going to perform the following. This is the inverse right here, okay. So what I'm going to do is, right now I have y of x. Wherever c I have x, I am going to substitute in the inverse. So what's going to happen then? Well, I have square root of x plus 2, and wherever I see x, remember I'm substituting in y inverse. So that's x plus 1 quantity squared minus 2 plus 2, right? So again, if you're confused what just happened, this thing, okay, is x, right? And wherever I see x, I am replacing it with y inverse. So one more time, wherever I see x, I am replacing it with y inverse. So that's how I am able to transition to that step there. I'm not done writing, okay, because I still have a minus 1. I'm going to continue reducing this equation now, and you're going to see that the positive and negative 2 cancels. I'm left with x plus 1 quantity squared minus 1. And what's the square root of a perfect square? Oh yeah, that's just x plus 1, right? It's whatever it is on the inside there. So I have x plus 1 minus 1, and finally I end up with x. So in other words, right, y inverse is also a function of x, right? I end up with it equaling x. This is, again, the identity, right? Re-exposing itself. Let's try this again, but in reverse. So let's say if I have y inverse of y. Again, now wherever I see x, I'm going to make the substitution of the equation for y. So I end up with x plus 1, right? So, okay, so bear with me here. So I have square root of x plus 2 minus 1 plus 1 quantity squared minus 2. Let's perform the simplification, the PEMDAS, right? So I end up with square root of x plus 2 quantity squared minus 2. I'm going to square the square root. So I end up with x plus 2 minus 2. And then lastly, I end up with the same identity again. So again, y inverse of y of x, right? Because that's what this is. Y is a function of x, right? So that's why I'm writing it like that, right? Y is a function of x. We end up with this identity. As it turns out, this is how we verify whether or not two functions are inverses of one another. So this is how we verify if two functions are inverses. This is the identity. The identity goes like this. F of f inverse of x will equal to x, but this is also equal to f inverse of f of x. Both of these must be true, okay, in both directions. But if you just solve if you solve either side, okay, that would be enough to suggest whether or not the functions are inverses. So verify if two functions are inverses. F of x is the inverse I should say f inverse, right, is the inverse of f of x. Must be true. The above must be true. So this is the key concept here. let's try to apply this, okay, for a third example. So now let's try to verify whether or not these two are inverses of one another. So according to that box right there, okay, if I take one and substitute it into the other, okay, so if I do this, right, of x minus 1 over 2, I'll end up with 2 times x minus 1 over 2 minus 1. So I have the fractions here, okay, the 2's will cancel. I'm left with x minus 1 minus 1. And I get x minus 2. You know what? We don't end up with the identity. So immediately we can conclude, okay, that these are not inverses. They're not inverses of each other. And the same could be said going in the other direction. Okay, if you were to substitute the other into the second, right, the first into the second, 2x minus 1, I'll end up with 2x minus 1 minus 1 all over 2. I'll end up with 2x minus 2 over 2. We'll end up with 2x, or we'll end up with x minus 1 instead. Okay? So we do not end up with, these two are not inverses of one another once again, okay, because they don't satisfy that identity.